Okay, perfect. We're live now.
What? We're live? Okay.
Yeah, we're live. All right. Hi guys. I can't. All right, I can't see you guys right now, but we're live on Twitch, and I'm here with Anthony. Anthony, do you want to introduce yourself?
Yeah, I am a program or product manager on Azure Functions. Actually, in Azure, working on some serverless things. I've worked on Azure Functions before. I am currently working on a product called Azure Container Apps, which is a serverless way of running containers. And I also work on Azure Static Web Apps, which is also a pretty serverless way to run some modern web apps that might have like a React or something front end, and some serverless APIs as a backend.
So these are all super cool technologies that you might be able to use for your final project. So you might want to tune into this project, especially because it's going to be a full thing. We're going to be building an API. And then next week, Anthony's going to be here guiding you through how to build a front end for that API that we're going to be coding today. My name is Emily. I'm one of your instructors. I've been answering questions, things like that. So I guess let's just go ahead and get started. So
All
we're
right.
first going to have a discussion. And Anthony, what is the discussion going to be about?
We're going to talk about different types of databases.
Yeah, and
And yeah.
we're going to be going through and differentiating between the different types of databases because there's lots and lots of ways to share, send data, store data, retrieve it. And there's different ways you can do that. And those different ways might be beneficial for different types of projects. So just because you're using, SQL doesn't mean that it's the best way for someone else's project. They might want to use NoSQL. And if you don't know what those words are, we're going to talk about that. So, Anthony, do you want to go ahead and share your screen?
Yeah, let's do it. So I just went ahead and Google just the different types of databases on Azure. You can do this on other clouds as well. Pretty much all the clouds have a variety of databases now that you can use to build your apps. And like Emily said, different types of databases are kind of used for different things. There is a lot of overlap though. So typically you can't really go wrong by choosing one of the popular ones, whether it's a relational or SQL kind of based databases like Postgres or MySQL or Microsoft SQL, or something that is kind of what people call NoSQL or non-relational, like a MongoDB, for example. So yeah, on all the clouds, you should be able to get one of these databases really easily. Or you can actually run them locally, and we can talk about the differences there between running them yourself or kind of just getting a database from a cloud.
So before we get started diving deeper into the different types of ways we can store data, Anthony, do you want to explain what's the difference between running a database on Azure versus doing it on your own computer locally?
Yeah, so there's probably quite a few ways of running a database. At the end of the day, there's a database engine that's running somewhere. The difference is whether you own the hardware, you run the hardware, or somebody else does it for you, and whether they install and run that database engine and totally hide the complexity of that from you, or you do it all yourself. It's like, so some people want to just do it all themselves and run it locally on like hardware that's sitting under the desk. They can do that. Or if you don't care about how to install a database engine on the server and kind of getting it all set up, set up all the backups and all the things that you should have for databases so you don't lose any data, or and setting up multiple instances of your database in case one kind of fails. You can always fail over to a new one. So you can do that all yourself, or you can go to the cloud and ask them to do it. And then another kind of difference between the two is if you're running your own hardware, if you're running it on your computer, you need a way to kind of share it, to access it. If it's, if it needs to be accessed from somewhere outside of, that computer, you have to set up the networking for it. And you also have to kind of worry about things like, what if I get a lot of requests to my database? Request is like if somebody's writing a record or reading a record. and you get a lot of it. Sometimes that could overwhelm your memory and your CPU. And if you run it yourself, you would have to either get more computers, or you have to kind of add memory and more CPU to your computer to make it go faster.
Yeah.
So yeah.
I think what I got from that is, running it on Azure, running it on serverless, it just saves you a lot of worries about all the different variables you might have to worry about. I would say, like, if you do have the chance, it'd be kind of cool for you to set up your own database server on your own computer. I always think that's like a great learning experience. But oftentimes, if you just need somewhere to store your data, you're working on a project, you don't want to worry about all of the other things that you might need to worry about if you're doing it on your computer. You could just go for serverless, have someone manage all of that while you worry about the actual core part of your project. I think this is a great point to transition into the different types of databases. So Anthony, do you want to go over just the kind of the basic types and what you might see in different Azure products, like what's Blob Storage categorized as, what's Cosmos DB categorized as?
Yeah, for sure. So yes, this is the page that you end up at when you kind of Google, databases on Azure. There's another way to kind of browse that kind of stuff, and I think it's up here. And I can choose something like you mentioned storage. So yeah, so I think at this point in the camp, I think you all kind of worked with Azure Blob Storage already. It's just a way to kind of store data cheaply in the cloud. And data in this case is most likely a file. So it could be an image, it could be something else. And I think so far, I think we've been storing images and stuff in there. So it's a really kind of, probably the least expensive way of actually storing this kind of data in the cloud. And there's actually like different tiers of it as well. So if you want to, store something that you just want to kind of write something there as almost like a backup, but you don't plan on reading it again, you can actually, change like, between hot and cold storage. So hot storage is something that you always want to have ready to read. So say you want to serve some images on your web app. You probably want that to be on hot storage so that it's always ready. So people don't have to wait when they access your site to kind of get the images. But in some cases, you might just want to kind of store something as a backup. You'd never plan on reading it again unless, a disaster happens. You can actually choose a cheaper type of storage, like almost like an even cheaper type of storage based on kind of your usage or your expected usage of it. So yeah, super flexible. And you're not limited to writing, images to it. You can pretty much store any types of files. Like we're kind of, because storage is so cheap, folks have been kind of writing, things like data to it as well. So this could be like log files, or like even things like, like JSON files and stuff like that. You can actually write to Blob Storage. And in the past, it's not super efficient to read from these things in real time. So that's why, like, we're going to talk a little bit more about databases later. That's why kind of databases exist, in that they're really optimized for writing data and reading data. But in the last few years, especially with the cloud, it's now a lot easier to kind of get the compute that's necessary to say I want to read, 10,000 files and actually extract, certain data from it. I can do this now fairly cheaply and really quickly in the cloud. So there's been a bit of a movement to kind of like just pretty much store everything in its raw state, because you never know, a year from now, I might actually, wanted to read like this property from this file that if I had, cleaned up that data, I might have lost it. So now there's like, there's a lot of folks that are kind of storing data as is, as they capture it. And then, later on actually running, queries over these, files. So it's still kind of like less common in scenarios like, like most apps that you build are using a database, but some folks are kind of like moving to this scenario where you're just writing stuff to Blob Storage, or, basically you see on the screen here, this thing called a data lake, which is literally a place that you chuck data into that you can read from later on.
So would you say a good analogy for blob storage could be like Google Drive, where you're just storing files and uploading it to the cloud?
Mm-hmm. Yeah, absolutely. And yeah, that's actually a really good, that's actually a really good comparison. So Google Drive has another layer on top, right? So when you click on the file, it actually opens up the files, and in an editor that you can actually edit the file in. But at the end of the day, it's stored somewhere, and it's probably stored on their version of Blob Storage somewhere behind the scenes.
Yeah, and now looking at blob storage, Anthony was talking about why there's blob storage, what uses that's for, and how databases are actually easier to write and read data often, because everything's organized in a specific format. So, how about we transition to that and let's talk about SQL, NoSQL, all the different types of and ways you can store and read data.
Yeah, for sure. So if we kind of browse the different databases that are available on Azure, and like I said before, most of these are available in other clouds as well. You can see that there's actually like many choices, in a sense, probably more than you would ever use in your lifetime. But it really, like they all kind of each exist because there's a different need. And as we talked about earlier, the main difference between the different types of databases is, like there is one class called relational databases and another class called non-relational databases. And like a relational database would be something like Azure SQL, MySQL. I think Postgres is somewhere here too. Yeah, Postgres is over here. So those things, you tend to store your data in in tables, and you query them pretty much universally for all of these databases using a language called SQL. I actually forgot what SQL means. It's like, maybe we should look it up.
Yeah, we can look it up.
What does
What
SQL
is
stand
SQL?
for? Oh, look at that. It's a structured query language.
Okay.
Yeah, so it's structured, and you can use the query stuff.
So it'd be something like select star, the asterisk, which means like everything, and then it'd be like from, and then whatever table, something like that. Anthony, do you want to pull up like an example query so they can see?
Yeah, let's open up the first kind of link that we find. So here it's like, select star from customers. So like in this case, there is a table called customers, and you're basically saying, hey, give me everything from customers. That's what star stands for. That's all rows and all columns. But you can actually change this. Actually, like, does it actually run?
I think, yeah, it does.
What?
Yeah, W3 School
Oh,
is a very
look
cool
at
website.
this.
Yeah.
So you can do things like, if I only want to get the customer name, I could just say I want a customer name and a contact name, and I should just be able to run this. And now I only get those two columns, right?
Nice.
And then I can also do some filtering, like
Where?
where contact name, yeah, equals. And then we kind of have to choose one of these, like, our friend Thomas Hardy here. Then you should only get the one row with Thomas in there. And then you can, if you want everything from that row, you can put a star there. Things like that. So yeah, so it's really kind of great for data that you already know the structure of. And yeah, and it's got, like you can use SQL to access it. And learning SQL is great because if you learn it once, say you learn it for Postgres, you can go and use it in MySQL as well. Like 80 or 90% of SQL is pretty much, the same across all databases. There might be some slight differences as you move from one to the other. But for the most part, if you can read and write SQL for one database, you can figure out how to do it for others.
Also, there's a lot of answers on Stack Overflow. If you just Google, like, if you don't not sure how to write a query, you Google exactly what you want and it just comes up.
Yeah, kind of like what I just did there. I didn't even know what the
Mhm.
meaning of SQL was, and
Mhm.
we Googled it.
Yeah.
So that's one kind of reason why you would use a relational database. Another thing that relational database is really good at are things like what we call referential integrity, which means that say these customers have products or something, you can actually create another table. If you can kind of imagine another table that kind of holds maybe like a shopping cart information for a certain customer. You would have basically product information in there, but you will also have a column called customer ID. And so for every kind of item that this customer adds to a database, you would go and add a row to that shopping cart table, and with that customer's ID. And then SQL allows you to actually join these tables together. So I can say, hey, give me everything from customer ID 4, or basically, like give me customer with an ID 4, but also join it to their shopping cart, so that you actually get records that include both information about the customer, but also their shopping cart contents in this case. So yeah, so SQL is really kind of powerful that way. It allows you to kind of store that structured data, but also like kind of join them to different things, so so that you can kind of pull back the data you want, pull it back in maybe even a different way than you stored it.
Yeah, that's a great introduction to SQL and like explanation of how it can be used. I have a very quick side note. If you're interested in how SQL can be exploited, like people can exploit SQL queries on websites to access information that they're not allowed to see, you can just Google SQL injection, and there's a lot of cool information on that. So now that we've talked a lot about SQL, what's the difference between SQL and NoSQL?
Yeah, so we kind of talked about earlier the benefits of SQL, which is the relational nature, which is you can have multiple tables, you can join them, and you can have like a really strict schema on the type of information that you store. So what typically you need to do to actually work with a SQL database or like a relational database is that you have to know a lot of this information up front. Like, I know that my customers will only have a first name and a last name, and maybe not something else, right? And then you kind of have to create these columns, and obviously you can still modify the tables as well, but it's you kind of have to know these things ahead of time. And then what you tend to do is you kind of you would kind of shape your data so that it matches the tables, and then you store it into the tables. So if you happen to, for instance, like we're talking about customers earlier, say you do want to track extra things for certain customers, you would end up maybe having to add an extra few columns to your customers table, or you might have to create a separate table to store this information and kind of do the join thing. But you kind of have to like make that decision, and then you have to kind of build this new database. And then you might end up with like basically columns that are only used for maybe a couple of customers, and then those are kind of blank for other ones. So with non-relational databases, you have a lot more freedom in how you store your data. So a lot of the more popular NoSQL databases or non-relational databases store basically what they call documents in JSON formats. So I think we've talked about JSON a bit in the like up until this part of the camp already, right?
Yep.
I think they're calling APIs, and APIs can return JSON. So JSON is just a way of kind of describing data in a form that's both readable by machines, but also you can sort of read it as a human too.
Actually, do you want to pull up an example of a document? I think that kind of show the JSON structure and then how
JSON.
flexible it is, like you were talking about, and how you can add additional fields.
Yeah. Oh, this is kind of gross.
Yeah.
But this is sort of JSON. So basically, like JSON is more or less just how JavaScript handles objects. So So there's a couple of things to point out here. So in a relational database over here, you can see that a customer has a flat list of properties. In JSON, you actually don't need to. So for instance, if this customer has an address, right? Yeah, so you can see that the street, the city, and the postal code are kind of like flattened into that record. In SQL or in JSON, what you can do is you can actually have the customer, but then have a property called, for instance, address. And then within the address, you can have the street and the city and the postcode and things like that. So that you have a lot more freedom about how you store this data. You can also store it as an array. So say, the earlier example of a shopping cart. I wouldn't necessarily implement a shopping cart by just shoving it into the into a customer kind of document, but you can actually create an array called shopping cart, and then you can just stick multiple like JSON objects inside of it, and that could be how you store your shopping cart. So you have a lot of flexibility in how you store something. So this is an example of an array. So you can actually store one or more of these things in here, and the database more or less behind the scenes just stores it. So if I were to now think of a new like a new property that I wanted to store for like a certain customer, I would just more or less just add it to that customer's document and then save it. So I will say though, like working with things like working with a non-relational database, you do have to have some amount of discipline to not just randomly write stuff everywhere, because you're typically reading and writing these things programmatically. So you can't just just write like for this one customer you write it like in one way, like with one name for a property. Like for instance, you might call it like it postal code in one and you call it zip code in another. Then it becomes a nightmare to read it back, right? Because you now have to know that postal code and zip codes are the same thing. So all of those things you might have you might have been better off using a relational database for, because you can kind of define what these columns are called. But typically, if you have just one app and that app is responsible for writing and reading data, then typically it's not a huge issue, because the app's always going to try to write it in one way. Just like unless you're unless you have some issues, you probably won't end up writing a like using zip code for for a couple of customers and postal codes for another. You typically would just have standard names, and then when you read it back, you know what they are. So, but that's another thing to kind of keep in mind. There's a lot of freedom, but you also want to be disciplined in terms of how you end up using that freedom.
Yeah, and I think kind of summing up, trying to visualize SQL versus NoSQL. SQL is just like your standard Excel spreadsheet, probably like the most familiar type of data storage that you're familiar with. On the other hand, you have NoSQL. I guess you can think of it like a file cabinet. Like you have a file, when you pull out those drawers and you have all those files. Each file it's a document, and each of the files, what's in the document isn't necessarily the same. But ideally, you would have standardized names, like Anthony was talking about, postal code versus zip code. Ideally, you would have like some kind of standardized approach to ordering things, but then again, you don't have to have the same details in each file in your file cabinet. And yeah, that's a much nicer way to visualize JSON than the previous example. But yeah, do you want to talk about this one?
Yeah, so this is like probably the simplest example, just like we saw here with customers. So this is how you might want to represent a customer in a NoSQL database. So this also shows one of the benefits of a NoSQL database here as well, because here a customer can have multiple phone numbers, right? So in a relational database, so like in the SQL world, what you might end up doing is that you might have phone number 1, phone number 2 as 2 different columns. And then, what if they have a third one? Then you have to add another one. But not all customers are going to have that. So you're just basically wasting space to have kind of these empty columns for these other customers. So document databases, so non-relational databases, typically allows you to kind of store, in this case, an array of phone numbers here, right? So you don't have to even know ahead of time how many phone numbers you want to support for a given customer, because you're going to always add more, and it's not extra effort, right? So that's some advantages of why you might want to use a document database like this.
And you guys might be wondering what kind of database you're going to be using during the camp. You're going to be using Cosmos DB, which is a non-relational database. So it uses documents to store information. And you'll actually notice that we use SQL query language to actually query for the documents, which is might be counterintuitive because you're thinking this is NoSQL, but you're actually using SQL. So
Yeah.
yeah, do you want to talk about that?
So like at the end of the day, like we Googled earlier, SQL is just a way to query data. And it just so happens to be before Cosmos DB came along that pretty much all relational databases use SQL, and then pretty much all non-relational databases don't use SQL, which is why sometimes people refer to relational databases as SQL databases, and then non-relational ones as NoSQL databases. But nothing is stopping you from using, like for a database engine to support SQL as a querying language, even if it's a non-relational database. And that's what Cosmos has decided to do. So behind the scenes, it's still storing your information as documents, so like as these JSON documents. But you can actually still use SQL to query it. And there's some advantages there in that a lot of folks already know SQL. So when they come to Cosmos DB, they don't have to learn a new language. But it also kind of adds some of the confusion because you can't really now call it, SQL, NoSQL anymore because there's SQL in this non-relational database. So, but for the most part, it's an advantage I find for Cosmos, because like I said, like when SQL, like 80% of it applies to all databases, and you just have to learn the nuances of the specific database that you're using for the remaining 20%. And that's no difference with that's no different with Cosmos DB. It uses a flavor of SQL. And like I think their differences are a little bit more extreme, because you're querying, at the end of the day, you're querying over non-relational data. So you'll find some, maybe some, bigger differences between how you might use SQL with a relational database versus using it with Cosmos. But the syntax is the same. If you look at SQL, you should be able to read it if you know how to read SQL. And Cosmos DB has actually kind of gone, kind of taken this even further, right? So like, the SQL, I think it was the first API that they came up with. So that's like, like you can kind of think of like, the one way of accessing Cosmos DB is using this SQL thing. But what they've kind of decided to do is, instead of making people learn Cosmos DB and learning, their kind of flavor of SQL, even though it's not super hard to learn, they decided to kind of support different APIs for Cosmos DB. So we kind of talked about APIs so far as kind of like, things that you talk to over HTTP. So like your web app might call an API, and the API may return JSON. But an API can be, how an application talks to a database too. So it might not actually use HTTP at all. It uses, usually uses another type of protocol that's more efficient. But yeah, so Cosmos DB has decided to implement basically what they call different APIs for accessing Cosmos DB. So I think we mentioned earlier, MongoDB is a very popular NoSQL or non-relational database. So Cosmos DB decided to support their protocol or their API. So if you have an app, and like Cosmos DB is very popular with, or sorry, MongoDB is very popular with Node developers. So you might have a Node app that's been written to work with MongoDB. So it pulls in the SDK from npm to talk to to talk to MongoDB, and so it's written to kind of use MongoDB that you might run yourself, or you might go to MongoDB and you can get a MongoDB in the cloud. But in Azure, what you can do is you can create a Cosmos DB and say that, hey, I want to use the MongoDB API for it. So now when you create one of those things, you can actually point your application, your Node app, at it. And this Node app only knows how to talk Mongo. It doesn't know anything about Cosmos DB at all. And but it still works because as far as your application is concerned, it's talking to a MongoDB database. Although in reality, it's actually talking to a Cosmos DB that happens to speak the MongoDB protocol or API. And they've kind of done this for other things as well. So Gremlin is a type of graph database. So graph databases is another type of databases. I don't know if we want to talk about too much into it, but a graph database allows you to do things like storing relationships. So one app that I always like to build is you can have an app. You can basically store data about airports and flights. And then you can sort of use a graph database to really easily kind of represent that within the database. But you can also query things really easily. So if I say I wanted to go from, Vancouver to London or something, and I only want, maximum of like one layover, a graph database is basically built for this query. Like, you in a Gremlin-based database, you would use a language called Gremlin to query it. But there are other ones as well. So you can actually write a query that says that kind of expresses like what I just said there. Kind of like all the flights from here to there, maximum one stop, really easily. And another kind of use for a graph database is to kind of represent social networks and things like that, because it's a lot more efficient to kind of store relational information between, I know this person, I'm friends with this person, but not that other person, kind of thing, in a graph database.
I think there's a couple of really good representations on that picture at the bottom: key value, column family, documents, and graph, which you were talking about.
Yeah, great point. So basically, what they've kind of chosen to do is kind of implement more of these APIs, so that you don't necessarily have to learn something new to work with Cosmos DB. So Cassandra is another one. So if you have a ton of data, you might want to use Cassandra. And there's another one called Table API too, which is a lot like a key value store kind of a thing.
Yeah, I think this is great because it's so flexible, and you're able to not only use SQL, you also have Mongo, which is the classic like non-relational database example, and Gremlin, Cassandra, and Table API, which you just talked about. I think this is a really good overall coverage of databases and the different types. So Anthony, do you want to go ahead and show everyone what we're actually going to be building, like what the final product is going to look like?
Yeah, sounds good. So we're going to be building out this map thing here. And I think Emily might have a link to this.
Yes.
Yeah, so this map is, it's behind the scenes. It's actually reading some documents from Cosmos DB, and the documents are really simple. I'll show you that a little bit later. It just has a GitHub user ID in it, as well as a longitude and latitude. And then I'm just going ahead and just kind of plotting this onto a map. Some of the interesting things that you can do with this map is that you can kind of click anywhere and you can move yourself. You can't move other people. So what it means is that it requires you to log in. So I'll open up another one here. So like go GitHub Map.
So if you open up that website, you can actually see Anthony making the changes live on the map. So It's very cool.
Yeah, you can put yourself onto the map as well.
Mhm.
But yeah, so if you're not logged in, like I am in this incognito window here, if I click, it'll ask you whether or not you want to log in. And it actually implements a login, so you can log in using your GitHub account. If you sign in, then the next time you click on the map, your face will appear. And yeah, and then if you click around, you'll actually move your little icon around. So you can kind of see here when I click around on this window where I'm logged in, it's actually updating live on all the other maps as well. So we're going to try to build this out in this week's stream as well as next week. So this week we're going to build out the API for it, as well as creating the Cosmos DB database. And then next week we will build a map. And we're also going to have another PM from Azure join us. Her name's Nuzhat, and her picture is right here. So she's going to join us next week as well. And I think it's going to be me, Nuzhat, and is it Shreya who's going to be joining us next week?
Yep, it's going to be Shreya. Yep,
Cool.
Shreya's going to be on the stream next week. Awesome. So you just talked about how we're going to build an API and set up Cosmos DB for this. So what's the general function of the API? Like, what are we putting in? What is it returning? How's it going to connect with everything?
Yeah, so we're going to create 3 different APIs. Actually, is it 3? Let's think about it. Okay, so we're going to create one API for just reading back all these documents, right? So yeah, so it's just going to, we can kind of call it get people or something like that. We're going to implement another API for writing, updating one of these documents. So and then next week we're going to talk about how to do it securely so that only I can update mine. But for this week, I think what we're going to build is just a really kind of simple API for updating anyone's document. And then next week, we're going to make some changes. And then we might, even add a third one where, if you don't want to read everything back and you just want to read it, if you just want to read my document, how do we do that? So, so those will be the 3. We can also talk about things like how do I delete a document, things like that. But I think today we're going to try to attempt to build 2 or 3 different API endpoints so that we can use next week to kind of build out this map.
Awesome. So what's our first step? Would you recommend setting up our Cosmos DB first, or?
Yeah, so let's do that.
Awesome.
So we can go to the Azure portal to create a Cosmos DB first.
And I'd say this is a pretty simple process. And you'll see how, while we're setting up the structure, you might notice how the non-relational structure of Cosmos DB plays into our setup. So yeah, you can go ahead and create the resource. It's always helpful to search stuff up, and you can click create like Anthony's doing. We're going to be using SQL. So you're going to want to click SQL because later we are going to be using SQL queries, right, Anthony, to query for our data.
Yep, absolutely. So, so I'll create a resource group. For some reason, I like putting dates in resource groups, so I remember when I create them. You don't have to do this; it's not a requirement.
Yeah, I have way too many resource groups.
Yeah. That's why I just started putting dates on it, so I know that if something is old enough, it's probably okay to delete.
That's a good way. Yeah, that's a good system.
And I'm going to call this the same thing, just so I don't get confused. Project. You can choose a location, and I'm just going to choose West US because I think that's closest to me, but you can choose one that's close to you. And as we're going to see in a little bit, you can actually distribute your data around the world too. So you don't have to choose one region. This is just the first region that you want to start with. And then here you get to choose between what's called provision throughput and serverless. So I'm going to choose serverless, and I'll attempt to kind of explain to you what the differences are. So if you choose provision throughput, you're more or less saying, hey, Cosmos DB, allocate me, this amount of, reads and writes. So, you kind of know, roughly how much traffic your app is going to expect. And I want to kind of pay like a fixed price for my use of Cosmos DB. So if you want to do that, provision throughput is great. then you can actually like somewhere, maybe on the screen somewhere, you can actually define basically how much throughput that you want, and then you end up just paying for it. So the pros of that is that you can you would you have kind of like cost certainty. Like, you know that if it's going to be $25 a month, you know it's going to be $25 a month. It's not going to be higher. It's not going to be lower. But some of the negatives are that, you know, if your database is very seldomly used, or you kind of expect spikes, right? So you all of a sudden, you know, you have like 1,000 users kind of coming to your database. You know, like your pre-provisioned throughput might not actually handle it, and you might have to know ahead of time that, you know, hey, it's you know, like I have a Black Friday sale or something that my site has to handle. You might have to go to your database and actually, you know, move the slider to be like, hey, give me more before the sale starts, and then you have to go back and move it back when you're done with the sale. Whereas if you kind of went with the serverless route, you're going to be paying a very small price by request, and it's like literally like pennies or fractions of a penny for a request. And you only pay when your app is being used. So typically the serverless one is more cost effective. Although I will say though, that if you're using Cosmos DB and you don't have any other version of Cosmos, like you haven't created a Cosmos DB in your Azure subscription yet, you can actually say apply the free tier discount. And what this means is that Cosmos DB comes with some amount of free, like, so it comes like, you know, these RU things, which are kind of like read units or resource units or something like that. I don't know what it's called. And each read or write is, you know, it costs you, you know, like a few RUs. So it's basically saying that you can do, you know, maybe a couple hundred reads or writes in a second. And you can get like 25 gigabytes of storage, which is quite a bit. So with the free tier, what it means is that if you qualify for it, which I think means that your subscription has not had a, like, this is the first Cosmos DB database in your subscription that's using a free tier, then you can say apply. And then basically, if you only kind of provision your database to 1,000 RUs and 25 gigabytes of storage, that is free. So I say, like, if you start off with Cosmos DB, that's probably the best thing to do, is to kind of go for this free tier first, because you only get one of them. I think it's only one in your subscription. And then after that, you can, you know, if you need more, you can create one using serverless. And that's usually the next cheapest way to do it. I've gotten by with, you know, just paying a couple bucks a month for, you know, for an app that's, you know, that's used regularly, but not heavily in the serverless mode. So those are the kind of differences. There's other checkboxes here as well. I'll be quite honest, I'm not even sure what some of them mean, because I always use the serverless one. So, and there's like other things that you can kind of click on here too. We'll worry about those later, maybe never. But I'm just going to call or click this create thing, because I know that it might actually take a couple of minutes. So I'm going to go ahead and create, and it's going to go off and try to create the thing. So,
while
any questions so far?
I think while that's the point, I think we can go ahead and talk about the structure we want on our non-relational Cosmos DB database. So
Yeah.
what things are we going to want to like record and store so we can retrieve later?
Yeah, so we can actually use, what did I do? So usually when I make Visual Studio Code bigger, my machine slows down because I have like few other Visual Studio Codes open. So I usually go plus and then wait and then plus and then wait, but I plussed it 3 times. I'm a little bit worried. It should be okay. I don't know what that is. So we can just use this thing here to kind of mock up what we want our customer, so what our kind of what we want our document to look like. Mm-hmm. So, and I can choose JSON mode here. So its code knows that we're working with JSON, so that it's going to go with highlighting and stuff. So to be honest, I think the thing that we're building is super simple. It's literally going to have 3 properties. So the first one would be basically an ID, and that would be, you know, a GitHub ID. So for me, it's Anthony Chu.
Oh, I love Copilot right there. It's
Yeah, so
going.
let's see if it knows. So, oh my gosh, hopefully it knows. This is madness.
It is crazy.
So if I wanted a name, I can put a name there and see what else it wants. Okay, that's my username. What else it thinks I need? Well, it thinks I need it. What?
Yeah, I think,
There's
yeah,
no way
right?
this works. Yeah, that's some other person.
Oh, wow.
It just puts some random other person in. But it's
What if it
basically
like
suggesting a
queried
bunch of stuff.
it queried your GitHub account for the
Yeah, no, that's yeah, I think we're still a couple of generations of AI away from that. But what I also want is longitude.
Oh, I
This
wonder what
knows.
longitude values it comes up with.
Yeah. It thinks it's that,
Probably.
whatever that is. We can actually try that out later. We'll do a
Yeah,
little
yeah.
copy and paste into the thing. And then we'll find out next week where it actually gets plotted to. It looks like it's somewhere kind of a little bit north of me. It's also kind of, I don't know. This might be like somewhere in like the UK or something. I don't know. I'm just totally guessing. I have no clue.
I have no
Geography is not
idea.
my thing.
Yeah,
Uh,
I can't.
but anyway, this is like kind of more or less the document that we want to create. Like I said before, you can actually do more. Like if you want address, maybe it is not in the UK.
Okay.
But like yeah, you can
Oh,
see that I can actually do stuff like this. So I can actually have a nested thing. Maybe I can
yeah,
do
you
the
can
thing
have
like
like
before.
nested. So inside of that
Yeah,
additional object, inside of the JSON object, you can have another array, and
yeah,
inside of the array, you can store even more things. So
yeah. So we can do things like phone numbers and stuff, but we're gonna do things really simply, which is just the longitude and latitude. Whoops, what did I just do there? And yeah, not even a name or username because the username is the same as the ID. That's literally what we're going to store. So it's not the most exciting thing that we're going to do, but we're free to add more stuff to it.
mhm.
And we'll kind of try that in a little bit. Hopefully we've stalled enough that the database is created, and it
Awesome.
has. So when it's done, it's going to give you this little blue button. You click on it and it goes to your database. So there's a few things you can do in a database. I can add a container. So a container is basically so basically what we just created is what's called a Cosmos DB account. And then within an account, you can have one or more databases. And then within the databases, you can have one or more containers. You can sort of think of a container as like a table, although it's not really a table. But you can sort of think of it that way. So you have an account that they can have multiple databases. We usually just put one database in there. And then within a database, you can have one or more containers. And the reason why it's called containers is because depending on whether you're using, for instance, something like the MongoDB API, a container is kind of analogous to like a collection. Like they might just have different names to what they might call a container, depending on the API. So they kind of use the generic name container.
So earlier I was talking about how it's kind of like a file cabinet. Would you say that a container is kind of like a different drawer on the same cabinet?
Yeah, exactly. So it's like a drawer with a bunch of papers in it. So we can actually we can actually create one ourselves. So we can go over here. There's a thing here called the Data Explorer. If I click on that, oh, I have this friendly person who I guess would tell me how it works. But
Yeah, that's nice.
yeah, let's assume that we know how that works. So I'll close it. And I have to shrink this a bit just so it fits on the screen. Hopefully it's still, visible. And it's actually like telling me to do things again. I'm going to assume that I know what I'm doing. So I'm going to say no. So what we've done here is, so far we just have the database account. So I think we have to create a database. How do we do that? I guess we just create a container, and within it, we have to create a database. So I'll make this a little bit bigger, and I can create a new database. So this database, I'm going to call bit project. And then I am going to give it a container ID. So for this one, I'm just going to call it people. And then a partition key, which is kind of weird. So that's one thing that we haven't talked about, and I think it's probably beyond the scope of probably the camp here, but like one of the big differences behind the scenes between relational databases and non-relational databases in general is that for a relational database, so like a SQL Server or MySQL or Postgres, the way to kind of add more compute power to your database is typically to add more CPU and memory to the machine that is running on. So you're like, this is called scaling up. So you always just kind of like make this machine bigger and bigger and bigger. But there is eventually a limit, right? Like like there's so many CPU sockets that you can use, so many memory kind of like sockets that you can plug your memory into. So eventually you'll run out of that. So your database will kind of grow to a certain size. And I've seen some monster kind of databases that you can kind of build that way. But at some point you kind of run out of how big you kind of get to a point where you can't make your server bigger anymore. So in a lot of the non-relational databases, in addition to not using tables and schemas and stuff like that, another thing that you will notice kind of more behind the scenes is that it actually uses a different model of scaling. So it tends to run on smaller servers, but it can run on more of them. So when you make a query, your data might actually be scattered across multiple servers and what we call partitions. So so in order to say let's say I store a document with the ID Anthony Chu. In order to pull it back, I actually have to give it what's called a partition key so that it knows to go to this one partition to pull it back. I think Cosmos can be smarter than this, in that you can actually tell it to kind of search across all the different partitions, they call it, to define your data. But that's not the most efficient way, right? So typically what documents will have is, or basically what you might specify for a container is, what property to use as your partition key. So, and then that's the thing that it uses to kind of figure out which machine to store your data onto. And then you kind of just have to specify that here. So here, I'm going to just use /ID because I'm going to call the column ID, or not the column, but the property ID. But anyway, that's a little bit weird. And hopefully I explained it well enough to kind of get by in the next hour.
Yeah, I think it's pretty good. Yeah. Explanation.
Yeah, but that's one of the differences. And sometimes, like you might end up, working with a non-relational databases. You might make a query and then you're like, hey, like I'm only getting like, back like 1/10 of my data. What's going on there? And it's because you probably, written your query in a way that it only kind of went after was a single partition, and that you're kind of missing data from the other partitions, something like that. So I actually don't even know what some of these things are, but let's ignore those. And that's probably not important as well. So I'm just going to click OK.
Yeah, so a lot of these concepts are probably new to you because they're unique to serverless applications, and just things like retrieving storage. And we even talked about global distribution earlier, how Anthony said you can spread your data out. Like it's not going to be stored in one data center, like in West US. It could be distributed across the world. So it's very interesting how people have come up with different ways to make data retrieval storage more efficient in terms of serverless, rather than just having everything on a single server running in your home.
Yeah. So you can see that the container called people is now here. It's a little bit small. I'm trying to make that bigger again. And it has some settings. We don't have to worry too much about it. There's not too much going on here. We'll learn about these things sometime in the future. We can actually create, like you can actually have set time to live on a document. So what that means is that when you create a document, you can actually tell it to keep it around for a number of seconds, and then it can automatically clean those up. So those are really handy for things like, hey, I want to write some data, but maybe, in a week, I don't care about that data anymore. It can automatically just get rid of them. So you don't have to kind of pay for the storage and all that. And I think you can also have like geospatial type things. I don't know how that works. And I probably should have prepared better because we are actually working with geospatial stuff. There are actually ways to write geospatial queries in Cosmos DB if you set up your data correctly. So if your data have like latitude and longitude, you can actually do queries like, give me, all the records of or all the documents of things that are within, say 5 miles or 5 kilometers from me. But maybe that's homework for you if you want to decide to do that. I think there are ways to do it.
Yeah, here's the thing about a lot of these settings, though. I think you won't really need them until you need them, if that makes sense. So
yeah,
if you come across something in your project and you're like, oh, I need this special feature, my project deals with geography, then you're going to Google and you're going to figure out that Cosmos DB has a geospatial configuration. So a lot of these things, I kind of just ignore them a lot of the time until actually I need them. And then I figure out, okay, I need to change this too.
Yeah, that's a good approach. Like the way that I kind of look at it is, I'll browse all these settings and I'll kind of like put in the back of my head that like they exist, but I try not to touch anything because I don't want to break it. So one thing that we can do now is in this thing, we can actually add some items. So I think I can right click here or something. How do I add an item? Upload new item. So here I can kind of create the record that I want to have, which I can just copy over from here. Just paste that in, and then I'll save. And then add some more stuff to it. For the most part, we don't really care about that stuff. This is like some Cosmos specific stuff that are kind of kept in there. The TS is kind of I think it's the last updated timestamp if I remember correctly. So there's, basically stuff there, but the key data that we care about are here. And I'll add another one here as well.
You can probably test out a query here too after you edit.
Yeah, exactly. That's what I was kind of thinking of doing. So I'll put Emily and Dave. So, and now what we can do is we can actually query from here. Where are the buttons? I just saw query earlier. So I can write a new SQL query. So, so the most basic query is select star from C, and C is basically the container. So I can go and execute the query, and you can see that both.
And you can see how it returns all the data in a JSON object, so it's easier for you to work with it as well wherever you're receiving it.
Yeah, and then there's stats.
Oh, never mind. My bad. It's an array. I can see.
Yeah, it's an array.
It's an array. It's an array.
So there's two things in there. You can also see here that like that particular thing cost me 2 RUs. So if you were to kind of manually provision a database, or sort of like use that provision throughput thing that we talked about earlier in the free tier, or you actually get 1,000 RUs per second. So in a second, I can basically pull 400 to 500. I basically run that same request 400 or 500 times and still stay within the free SKU, or the free tier. So yeah, so it's really cheap that way. And I can actually quickly kind of go Osmodb Pricing. And yeah, this is also a little bit complicated to read. But if you're on free, you're fine. And if you're on a serverless one, you can see that for 1 million RUs, it would cost me 25 cents. So if I did that same operation, my math is terrible. What is it, like 400 or 500,000 times? It would have cost me 25 cents. So yeah, so it's basically free for a small app. You obviously have to worry about this if you have a bigger app and you're like kind of like serving, like tons of traffic, or have a lot of requests, or your requests are really complicated. They actually cost more RUs. But something really simple, like writing a little simple document or reading it back, like it's literally, you saw here, 2 RUs, right? So it's the free tier or the serverless tier should be more than enough for you to do it for free, or almost next to, basically next to free. Another thing I want to point out is that Cosmos DB is actually super fast. So everything is kind of like indexed by default, and what indexing allows you to do is, basically retrieve things really quickly. So so for Cosmos, yeah, like most queries are like under 10 milliseconds. So so it's great. I just noticed the time, so I just want to make sure that we start building out the API soon. So I'll just quickly point out another thing. So we inserted a couple items in there already, which is great because we're going to need those later. I'll kind of point out a couple more things, or maybe just one more thing. We talked about regions before. Am I not seeing this? I thought there was a way to... I wonder if it's because it's a serverless account and I can't spread them across regions.
So is it the global?
Oh, did you see it?
I think it was global distribution was a setting when you first deployed the resource.
Oh, and I said no.
Well. It was in a different tab, so unless you clicked on it, you wouldn't have.
Yeah. Okay. Well, I can't show you anyway. But what you end up seeing is, if you actually chose the right thing, which I obviously did not, is sort of like this map that we saw earlier. Something that looks like this map, but like with all the regions in Azure. I think there's like 60 regions or more now. So you can literally, you kind of have to pay for each one of these, so don't just click them randomly. But say you wanted your data to live in both, like the US and also in Asia, you can actually click in 2 locations. And what happens is when you write data on either side, it'll actually just automatically get synchronized between the 2. So you can have an application that's running really close to your customers or to your users, that's accessing data, that's reading data from a Cosmos DB instance that's really close to them. So you don't have to pay for, like the speed of light to actually read it from over here. It'll try to do that all for you. And you can, you can click almost as many regions as you want and to spread this data around. But like I said, each one of these regions will kind of cost you more money. So don't do it unless you need to, but that's a really kind of powerful feature. And then another thing that that you can do here is setting what's called a consistency level. So things that are spread around the world. So obviously when you kind of do something, it doesn't just happen all at once. So like, I think they have some animation here to kind of teach you what the differences are. But you can actually choose to say that I want, like things to appear like they are all kind of happening at once. Or you can choose eventual consistency, where you just write to one region, and there's really no guarantee to when that data is going to be replicated to another region. It's just going to get there eventually. So each one of these have different, performance kind of characteristics and things like that. But you have that, ability to kind of, decide how consistent you want your data to be. But yeah, so that's the database in a nutshell. Before we run out of time, let's go and build out our serverless front end, or not front end, API.
Yeah.
So I'm just going to go and open up Visual Studio Code from this folder that I have here.
Mm-hmm. And just like we already said before, but our structure of our document is actually very simple. We're just storing 3 keys or attributes, whatever you want to call it, or fields. It's just going to be ID, longitude, and latitude. So which part of the API are we going to build first? Which one of them, I guess?
Let's because we already have some data in the database, let's do the one that pulls back all the documents.
Awesome. Yeah. So that could be called something like get people.
Yeah. So so what we have to do now is first create an Azure Function app locally on my computer. Mm-hmm. Let's go here. I've never actually used this new UI before.
Really? I've used it a couple times. I feel like it's about the same as original.
Yeah, the thing is, like, I think stuff moved around. So like here, I can only create stuff in Azure. Maybe in this workspace, I can create a new. Yeah, so I can create a new function here. I actually have no idea how this works. So I'm going to go and just use my friend. The reason I don't know how this works is that I almost always use the command palette. So that's Command Shift P on my Mac, F1 or whatever. And I
So
can
do
search for.
we
Yeah, go
want to
ahead.
deploy this on we want to deploy this onto the cloud, right?
Yeah,
After
eventually, yes. So, but
eventually.
right now I want to create the project locally so I can work on it locally. I can debug it locally.
Okay. Mm-hmm.
So I'm going
Exactly.
to search for Azure Functions. So I already have the Azure Functions extension installed.
Mm-hmm.
Functions, create a new project. So I'm going to go and create a new project. Assuming somewhere here I can find the right plus button to do the same thing, but I'm not going to waste our time finding it. I'm going to do this in JavaScript. And my function is going to be an HTTP trigger. I'm going to call this get people. And then I'll just kind of have it anonymous.
Awesome. All right, so now we have our template up.
Mm-hmm.
What are some things we need to install? Do we need to install anything?
So we could, so like there's a couple of ways that we can do stuff with this database. So one is for pretty much every language that we want to work on. Cosmos DB has what's called an SDK that you can install. So here you can npm install some npm package that allows us to talk to Cosmos DB. And you would basically write code here, read people from, come on, DB. And then I don't actually know, this is a terrible suggestion. I was hoping that it would actually give me some example code here. It might if I kind of go in, ask it to figure it out.
Wow.
Or maybe it won't. I don't know. But you basically would kind of like, you would first say create a client, and then I would set up a connection string. I would have to, like find the collection or the container that I want to talk to, and then execute a query to it.
Right.
So that would be something like 10 or 20 lines of code that I can write. But what Azure Functions also has is this concept of triggers and bindings, and I think we've probably talked about this in the past. But there's basically a binding for Cosmos DB. So that allows us to basically talk to Cosmos DB without installing any libraries, and that's
awesome.
what we were going to do here. If we're interested, we can actually, like maybe between this week and next week, I can also, add an example that actually uses the SDK to do it.
So in the camp, in the curriculum, the Cosmos DB section, they're actually using the SDK. So I think this is a great opportunity to learn the other way, which is triggers and bindings, and actually use that with Blob Storage when I was coding my own final project. I used a trigger and binding for whenever someone uploaded an object to Blob Storage. So I'm interested to see how this works with Cosmos.
Okay, great. So let's do that now. So I basically removed everything from the, that's probably too much. Bring back what we had before. Go. All right, so so I'm going to do a couple of things. So the first thing that I want to do is so there's two different types of bindings, maybe three, because a trigger is kind of considered a binding too. So you can have a trigger that basically fires a function whenever a change happens to a document in Cosmos DB. We're not going to use that today. And the two other kinds of bindings that you have are what's called an input binding and an output binding. And an input binding can read from a data source, and then you can have access to the data source within your function. And then an output binding, you can write to a data source, as you can kind of imagine. So we're going to use both of them in this API. So the first thing that I'm going to do is I'm going to go over to this, to my function app. So this is my function. So each function just lives in its own folder. I'm going to get rid of this sample.dat thing. For some reason, it always gets created, and I never use it. So we just looked at the function body itself, and sort of the bindings are defined in this other file in the function called function.json. So currently, it just has an HTTP input binding and an HTTP output binding. So that's how you can implement, that's how it implements the API or an HTTP API. But I can add to this. So I can add an input binding for Cosmos DB. So there's a couple ways I can do it. I can literally go and Google Osmodb Azure Functions findings. And then it kind of tells me what to do here. And I want an input binding. So I can kind of copy and paste this thing here. So that's one way to actually set up that binding. So another way is actually right-clicking on here. And because I have that Azure Functions extension installed in VS Code, I can say, where is it? Why is it going? Oh, it's right here. I'm like, why can't I see it? Add binding. And I can say I want an input binding. And I can choose from Cosmos DB. And so this can, like, and then I can kind of just name this binding. I'm going to call it people. And then this is a database where I'm going to read from. So the database is called, I think I called it Bit Project. And then the collection, I called it people. And then I'm going to need a connection string to it, right? So like my app needs to know how to talk to that database. So I'm going to go and create a new app setting for it. And I will call it that.
This is super cool because it's just it's basically a UI, but it's like local.
Mm-hmm.
So you
It
have
is.
to go on the Azure portal.
Yeah, except oddly enough, I'm not seeing the one I just created. So what is going on here? So I'm going to try a couple of things, get out of this.
Was it called Bit Project Demo or?
No, I just called it with the date and stuff. Was it there?
Oh, wait, were you selecting, what setting were you selecting for? Was it asking for the function?
Yeah, I'm just going to see if I can browse for it here. Like there's so many more here. Why is it not
okay,
there?
I see it right there, yeah.
Yeah, it's right here.
Yeah, it's that one.
So that's the one that I wanted, but for some reason I'm not seeing it. So
let's try again.
What was I doing? I was adding a binding. It's like demo fail number 1 already. We're barely here. Okay, so this is going to be called people. I'm not just going to copy and paste. That's fine too. Bit project, and I called it people. Create a new app setting. This thing. Hey, there's more stuff. There's more stuff. Was there more stuff before and I just didn't scroll? No, there's definitely more stuff.
No, I don't think I didn't see a scroll bar.
Yeah. So anyway, like I think it talks to that other extension, and maybe that extension I just need to refresh it so it pulls more stuff. I don't know what happened there. We'll call that a glitch. A glitch. It's a technical term. The document ID. I have to remember what to put there. I think it's called ID. Oh no. So if I want to read a single document, I can put an ID there. But I don't. I want to read from everything, so I'm just gonna leave it blank. And then here, I want the partition key of the thing that needs to be read. I have no idea what this means. That's also optional. I can also write a Sql query. So if I want a custom, like way of actually reading from that database.
We just want to get everything, right?
Like, yeah, but we just want to get everything, so I can leave that out as well. So it's going to generate this thing out for me. Nice. And because I've done this before, I know that these empty values are actually basically Azure Functions is going to get upset at those. So I'm going to remove them. If you end up getting a cryptic message about something being null or something, it just means that, because we kind of chose nothing for them, it created those empty strings. Just delete them. Everyone will be happier. So that's what I'm doing here. So I think that's kind of all I need to kind of read from this database. Remember, the binding name is called people. So what I can do here is I can just add another one. I can actually call this whatever I want, but I'm going to call it people just to match. So the way this works is that, I think anyway, from what I remember, we can, if we declare more input bindings, we can add more arguments to our function, and whatever we kind of pull from that binding will appear there. So in this case, the list of people will already be there. So I'm going to remove pretty much everything here. And the thing that I want to respond with is basically just what I pulled back from the database. I can obviously do more things here if I want to modify the data I got back from the database before I return it, but I'm literally just going to return it. in the body of my function. So if I've done everything correctly, I've just pressed F5 to run this function app. It's going to go ahead and run it. And here we go.
Awesome.
So if I go and just click on this, where did it open? It opened on one of my screens somewhere. Okay, fine. I don't know where it opened, so I'm just going to copy it. I'm going to copy this
When that
and
happens,
go to a browser that I know I want to use. Here. You can see that it already kind of pulled back all the data without me really writing any code. So I can put a breakpoint here just to kind of see what happens. If I refresh this page, it'll actually stop at the breakpoint, so I can inspect all my stuff. I can actually look at my context here, which has, oops. Is it gonna, come on, wake up. No.
Can you use the variables?
Yeah, I can use that. I'm usually lazy, so I hang on over here. But you can sort of like browse the different, things there. And if you actually mouse over people, you can see that I got 2 documents back. And I'm literally just returning as the body.
So that was how many lines of code? 5?
1.
Well, technically only like 1, because you only modified the context.res.
Yeah, like there is like some other declarative stuff we have to do over here, but it's in terms of codes, in terms of lines of code that you need to write. I think yeah, you just have to write that 1 line of code there, and we're good to go. So we have our first function already. So let's quickly add the second one. So let's go over here. No, do I go here?
The next function is going to be actually adding an object, right?
Yeah. So I'm going to attempt to.
So I'm assuming this API, I guess, is probably going to have more lines of code we're going to deal with because we're receiving information.
Yeah, sort of. I should figure out how many lines of code. I don't think it'll be too many.
But it'll be slightly more complex than the first one.
Yeah, if you want to be secure. But I think this version that we're building is going to be less secure. So it won't be as complex. So I think there's a way to add like a function.
Yeah.
Okay, I create a function here. And I can say I want another HTTP trigger. And this one is called create or update person. Probably a better name for it, but that's what I'm going to call it today. So I can see that get created here. Again, I don't like this file. I don't know why it's there. I'm going to get rid of it. Bye. Yeah, same as before. I'm going to add a binding here, but this binding that I'm going to add is an output binding.
So it's going to directly send that information to Cosmos. So instead of pulling it, we're modifying.
Yep, and we can see there's a whole bunch of places we can send data to. Emily, you kind of mentioned that maybe you might have used the blob storage one before. If I want to write to queues, for example, it's literally, right here. And then you can, with a single line of code, you can write out queue messages. There's a bunch of other stuff as well. So if you want to send an SMS, again, 1 line of code. Send an email, also just 1 line of code. So I am going to use Cosmos.
So this is a really cool feature in Azure. So we've been using mostly SDKs and such to connect applications, different resources in Azure. And now you're seeing another way you can do it. Very low code method, very simple. It's all in the UI. You have triggers. So you said that triggers are technically a type of binding, right?
Yeah, it's an input binding that happens to also have a trigger kind of an aspect to it as well. So, but at the end of the day, when a trigger fires, say you're listening to blob being created, your function's going to start, or your function's going to be triggered, and when it gets triggered, you're also going to get the contents of your blob passed in to your function. So in that way, it kind of behaves like a binding. An input binding as well.
So I guess like in terms of dealing with data in Azure, bindings are like a really good way to transfer that information across resources.
Yeah. And depending on what you're doing, sometimes, yeah, like I would always start with seeing if a binding can do it, because it's less lines, fewer lines of code that you have to kind of write and maintain, and maybe fewer libraries that you want to pull into your app, so your app even runs faster. But there are things that like, we're not going to have time to kind of like, create an endpoint that deletes a user, for example. You actually can't currently delete things in like using just bindings. Because bindings are, like just the way that it's written, you can output things, which means, adding or kind of updating things. But there's not really a way to actually, say I want to delete something. So, so in that case, you still have to bring in the Cosmos DB SDK and delete, basically run, write the lines of code to delete a person or to delete a document. So I'm going to call the output binding person, because we're kind of creating or updating a person. And in the database was called bit project. In the collection was called people. And I don't want to create the collection automatically because I already created it. But you can actually tell the binding to create the collection automatically. And I can just choose the same Cosmos DB database as I used before that was stored in that variable. Partition key, it's optional. And this one here. So this is all information that it needs if it were to automatically create a collection, or like a a container for me. But because I'm not going to do it. I'm just going to blank it all out. So it's just dump that out here. And again, I know the thing is going to get upset, so I'm going to remove it. And yeah, it looks like that's already done there. So we're good. So our function is correctly set up to have an output binding that outputs to the people collection or the people container in my database that with the connection string that's stored here. In case you're wondering, the connection string is stored here automatically. I'm not going to scroll too far to the right because it actually has my password in there. But that's where it gets written. And you can see that it's grayed out in Visual Studio or in VS Code. It means that it's not going to get committed to source control. So you don't have to worry about, kind of your secret escaping everywhere. And this thing just, references that setting. So let's go and update this function content here. Again, I don't need any of this stuff. So what I do want, okay, not that, but it's close. I'm going to say I want to get the person. So the person that's, so it doesn't know that. So I'm going to basically make a post request to my function. So in order to get the contents of a post request, I get it from the body. So this is exactly what the line of code that I need to write. So now I have basically the person kind of stashed away in this variable here. And then in order to write to that database, I just need to go context.bindings dot, and I called it, not this, I called it person. So I'm going to say person equals person, which is the body.
There we go. That's
the one line of code. And I like to return kind of like the thing that I just wrote. So I'm going to return person here as well, but that's kind of optional. But yeah, but this is the one line of code that I need to write to the database. And how it really works is that when you're writing, no, what am I trying to say? Yeah, so if the document doesn't exist, it's going to try to create it. If the document does exist, it's just going to update it. So in the code that we're going to use next week, we're going to, have a GitHub login component to this. So you can't just write to any person. So you can sort of imagine some code that we're going to write here between these two lines to make sure that the person, like, I guess maybe I shouldn't use the word person, but the person that the person sent in, actually has the same username as the person that's logged in. And then if not, we're actually going to blow up, or basically we're going to make sure that like we're going to write some basically some if statements here to make sure that the person, or like basically the thing making the request is logged in as the person that we're trying to write out to. Otherwise, we're just not going to do it.
And then this is just a preview for next week. How are you guys going to do the authentication? So are you going to be using GitHub? How are you going to connect GitHub to the Azure function, I guess?
Yeah, so today what we're going to do is we're going to deploy our Azure Function app just as its own Azure Function app to Azure, and I think we've done this before in the previous weeks. Next week we're actually going to use another product that I work on called Azure Static Web Apps. And Azure Static Web Apps is really great for if you want to host an app that's built with React or Vue, basically a bunch of static content. But typically those static content needs to talk to an API, and that's where like this serverless API comes in. And you can actually in the same project have your React app as well as your function app together. And then Azure Static Web Apps is actually able to deploy both of those for you. So you don't have to go and deploy to a separate function app at that point. So now you basically have an app that has both a React front end and some functions in it. And then you can really easily, without writing any code, add authentication on top. You can say that
nice.
I want to protect my in this case, my update or your creator update person route to only allow people who are authenticated to call it. Otherwise, don't allow that. And that's how we're going to build that out next week, is that we're going to use the built-in authentication with Azure Static Web Apps. And then we're going to integrate, basically write a few more lines of code here to make sure that we're only allowing the person who's allowed to write that document to write it. Otherwise, we'll reject it. But for this week,
that sounds super cool, because I think it just shows how much Azure products, like, it kind of provides solutions where you usually when you're writing authentication, it's like a whole process and you have to create a GitHub app, et cetera, et cetera. So that's super cool how everything's just completely automated and it's like built in there for you.
Yeah, it's built in. So we'll talk about that next week. So this week, we're gonna have this insecure version, which we're just gonna write whatever document the person passes in into the database, which is a horrible thing. Don't do this on a real app. But like I said, we're just a few if statements away from a secure app.
All right.
We're just not.
Do you want to test this one out?
Yep. So we're going to go and F5 this. And while that's starting, actually, I don't even know if I have Postman installed. So currently in the in the camp, we've been using Postman, right?
Yep, we've been using Postman.
Do I have it installed? I don't. I'm going to use something else.
That's totally fine.
Which I think might be useful to kind of learn other ways to make to make requests. And something else that we probably want to clean up a little bit, some other time is, like this one, we probably only wanted to respond to GET requests. And for this one, we only wanted to respond to POST requests. But currently, you can use both. But it almost doesn't make any sense to call GET on this one. So I'm going to go ahead and copy this, because I know we're running out of time a little bit here. I'm going to just open up a new file, which is not that. And so I have an extension installed. Where are my extensions? This thing is called like REST client or something. But yeah, so I installed this REST client in VS Code. And it's great. It allows me to basically have a type of document or like a type of file in VS Code for making HTTP requests. So I'm going to click here and I'm going to say HTTP request or HTTP. And if I save this file as, actually, no, I'll save it. I'll save it as, basically request.htp, and I'll save it one level above.
This is pretty cool, because then let's say if you push this onto GitHub and someone else downloads it, it's like a built-in way you can just test locally.
Yeah, so I'll kind of quickly show you the first one, because this is the easier one. So if I just say get, so that's a method. and yeah, and just that until Copilot to stop talking. I can just click send request, and then it's going to send the request. Oh, it's going to hit my breakpoint because I still have it there. It's going to send requests and actually basically, return the same data, right? So
Oh,
we
that's
could have
super
done this
cool.
in Postman. Obviously, it's a little bit lower level, but it's great, partially, and also because, like you mentioned, we can source control this file, right?
Right.
And if I want to have another request, I just need to like put 3 pound signs, and then I want to go post. And I'm going to post it here. Oh, not that though.
I guess I would say like Postman, it has like nice features on it. And it visualizes your data nicely. But I guess this is great for like just testing because you're coding on VS Code. You just need to switch a tab and you can. Okay, so you
Yeah.
can add headers too.
Yeah, so I can add headers. And it actually has like, really good intelligence. I want like this is going to be application JSON. And look, see, like Copilot's already telling me I could do that. That's actually pretty close. I'm actually going to go and grab this thing here. And I'm going to add a new one. So there's a new person called Ganning. And yeah, so I'm going to go ahead and send this request. And hopefully it works. See, it said okay. So
I guess we can use get. Let's use the get request to check if it.
Oh, you're right. I was like, let's go to the database. We don't have to do that. We just click. Yeah, it's brilliant. Okay. There we go. Ganning is in the database. So that's how easy it is to kind of write it. And if I kind of wanted to update where he is, so say maybe near the equator, I can send that request. And now when I kind of do the get request here,
and
you can see that it got updated. Right. So,
Nice.
so yeah, that's kind of how easy it is to kind of write this thing. I don't know if we need to kind of go through the process of deploying it because I think we've kind of deployed the app a few times. I can if you want.
I think we're good with deploying. I think maybe they've done it a lot.
Yeah. So there is an extra thing that we do have to make sure though that that after we deploy that we make sure that this environment variable or this app setting is set on the function app that's in Azure so that it knows to talk to the same Cosmos DB account. Otherwise, it's going to blow up because it doesn't exist.
Yeah.
But that's really the only change that you have to make. Otherwise, it's the same, deploy function app next. And yeah.
All right. Well, that was a lot simpler than I expected, actually, with bindings. Yeah, especially with, I think when I was working with bindings, I Googled and then I copy pasted the template and then like found all the values and put it in. So seeing that, with extension, it's super simple. You just have to click a couple things instead of having to find everything.
Yeah.
That simplifies the process a lot. All right, as we round off this first session, the first part of making this super cool GitHub map, Anthony, do you have anything else you want to add?
No, I don't really have anything. I'll show the app again so that we know what we're going to do next time. Yeah, so this is the app that we're going to use API to build out next time.
I was thinking when we were drafting up like the structure, I was thinking another cool feature we could add is like a comment field where you could hover over someone's icon and then you could see like someone say like, hi, my name is so-and-so.
Yeah.
I'm located here. Nice to meet you. My contact details are here. So it'd be kind of like a cool interactive networking kind of thing.
Yeah. Yeah, that's a great idea. We can see if we can build that next week. If we can't get that in there, we'll have we'll just add that as homework for everyone to
homework for you guys to work on.
Yeah, exactly.
All right. Well, I think that's all I have too. I hope that was a great overview of Cosmos DB, how you can actually work with it using bindings instead of writing like 10 lines of code, copy pasted from documentation. Um, but yeah, that's about it. I hope to, well, Anthony and I both hope to see you. I won't be there, but sure we'll be there. Hope to see you next week. And we'll just be finishing up the app, creating a front end using Azure Static Web Apps, which is really good if you want to make a front end for your project. So I would recommend tuning into that.
Yeah, and that's all
And
free. So
yeah,
so yeah, so that's another good part about it.
exactly. All right. See you guys. Bye.